Intermediate Algebra, Section 8.3, Writing Equations from Solutions. If we wish for two given numbers to be solutions of an equation, we can create such an equation using the principle of zero product in reverse. So here they're asking us to write a quadratic equation having the given solutions. Well, here's our solutions. Thinking backwards through that process, we would have x is equal to a -3 or x is equal to 6. If we set these equal to 0, taking our value on the right to the left, it changes signs by adding 3 to both sides. And we have the following. Bringing the 6 to the left gives us x minus 6 is equal to 0. And again, this is from subtracting 6 from each side to have everything on the left. And again, thinking about how that principle of zero products work, we set these equal to 0 and solve for our variable. Well, think about what the step was prior to this. We had a product of these two binomials that were multiplied together that equaled 0. And these were the result from factoring our quadratic equation. So again, working in reverse, we'll multiply these two binomials together. Multiplying first terms together, we get an x squared. Outside term would be a -6x. Inside terms multiplied, 3x. Last terms multiplied together is a -18 is equal to 0. Simplifying this further, we have similar terms with a -3x minus 18 is equal to 0. We have our quadratic equation that resulted in those solutions. And if you think about this, this has been the direction that we've been working so far. We've been given an equation, factored it, used our principle of zero products to set each of those factors equal to 0, and then solve for the variable. Now we're going from the solution to recreate the equation. It doesn't matter what type of form our roots are in, the procedure is the same. Here they're telling us we have a solution of -5i or 5i. Putting these in standard form, bringing the term to the other side changes its sign and sets it equal to 0. Likewise, we will have the same with this other value. Then, going through those reverse steps, we will multiply the two binomials together, setting them equal to 0 with our principle of zero products. Multiplying first terms together, we get an x squared. Since these are conjugates, when we multiply the outside, we get a -5i. When we multiply the inside, we get a +5ix. These are opposites, so they cancel out, leaving us with just the last terms multiplied together, a negative times a positive. 5 times 5 is 25. I squared is equal to 0. I squared is -1, so we have an x squared minus 25 times -1. And simplifying further, our equation that has these two roots came from x squared plus 25 is equal to 0. In this example, they're giving us that we have only one solution, but the instructions were to create a quadratic equation. This just simply means that we have one repeated solution. And so x is equal to -2 or x is equal to -2. Same procedure, bringing those terms over and putting them in standard form. To the other side changes its sign. Multiply the two binomials together to create the original equation. First terms multiplied together is x squared. Outside would be a 2x. The inside multiplied together would be another 2x. 2x plus 2x is 4x. Multiplying the last terms together gives us 4. So the resulting equation, at least a version of it, and keep in mind we could multiply all these terms by any number that we wanted to have an equivalent equation that would ultimately simplify to a one repeated solution of -2. Solutions that are irrational work the same way. We will set x equal to each of those, working our way backwards or in reverse order to generate the equation that they came from. Putting these in standard form, taking the term to the other side makes it positive. Likewise here. Then the reverse of our principle of zero product gives us the multiplication of these two binomials. Multiplying those binomials together, first terms we'll get an x squared. Outside will give us a 3 square root of 3x. Inside terms multiplied together, square root of 3 times x. And last terms multiplied together, we'll have a 3 times the square root of 3 times the square root of 3, which will give us a 3. Whenever you have a radical times a radical, it gives us that value, and ultimately a 9 when we simplify. Combining like terms, we have 1 square root of 3x plus, or I should say 3 square root of 3x plus 1 square root of 3x makes 4 square root of 3x, recognizing that x is not underneath the radical. And as I said, the 3 times 3 is 9. So this would be the quadratic equation that resulted in those two irrational conjugate roots or solutions. We can take this up actually higher. Here they're asking us to write a 3-degree equation having the following solutions. This isn't quadratic, but it's a 3rd degree. It means because of a 3rd degree that there's 3 solutions, and here they are. X is equal to a -3, or x is equal to a 2, or x is equal to a 4. And very similar, we'll put these in standard form. Taking the values to the other side changes their sign. Subtracting a 4 from each side puts this in standard form. And again, the reverse through the the principle of zero products, we will multiply these binomials together. And recognizing we can only multiply 2 binomials at a time, you can only multiply 2 things together. Order doesn't matter, but if we multiply the first 2 together, we will end up with an x squared with the first terms. The outside would be a -2x. Inside multiplied together is 3x. 3x minus 2x leaves us with an x. Last terms multiplied together would give us a -6. 3 times a -2. So there's the first 2 binomials multiplied together. We're then going to multiply that result by our 3rd binomial, and using distributive, x times each one of these terms will give an x to the 3rd power. X times x is x squared. X times -6 is -6x. Then we'll go to the second term. -4 times x squared is -4x squared. -4 times x is -4x. Negative times a negative is positive. 4 times 6 is 24. Combining like terms, we have an x to the 3rd. We have an x squared minus 4x squared is a -3x squared. The linear terms, a -6 plus a -4 is a -10x. And then we have the 24 as our constant term. So there's our 3rd degree equation that has those as solutions.